Hey there. Now today I'm going to teach you how to convert decimal fractions, so numbers with a decimal point, to binary, and it is a little bit different, and I hope you'll stick with me for this one. But I'll show you how to do the division algorithm and the multiplication algorithm, which is a little bit different. Let's get right into it. Today I'm going to use yellow. Okay, let's choose a decimal number. 5,323 point, let's say 250. How do we convert this to binary? Well, if you watched my video on the binary division method, you know that you continually divide and then you get your most significant bit to your least significant bit. But what do we do with this? Do we continually divide that? Well, no, we don't. We actually do the opposite of that. Because if you remember my explanation at the end of that video, when we're dividing by the base of a number, we're actually pulling out each number and turning it into a remainder, and that remainder is our binary number. And so you actually have to multiply. And I'll show you that in an example. Let's do this right now. Part 1. 5,323. Let's divide that by 2. We get 2,661.5. Remember, when you divide something in half and you get 2.5s, that's a remainder of 1, because 2661 plus 2661 plus 1 is 5,323. Okay, so the remainder here, when you divide this number in half, we get a remainder of 1. Now 2661 divided by 2, that is 1,330, remainder 1. Great, good so far. Now remember, of course, when you're continually dividing, you write down the remainder, but you don't divide the number with the decimal point afterwards. You just divide the whole number, the integer that's called. So even though this is a 0.5, we only divide this bit here. Okay? Now 1,330 divided by 2, 665. Remainder 0. Divide that by 2, 332.5. So remainder of 1. Now you can guess what I'm going to keep doing. We keep dividing until we get to 0, and we don't divide 0. So 332 divided by 2 is 166. So no remainder, just 166. Let's divide that by 2. 83, remainder of 0. Divide that by 2. 41.5, so remainder of 1. 41 divided by 2 is 20.5, so that's a remainder of 1. And 20 divided by 2 is 10, remainder 0. 10 divided by 2 is 5, remainder 0. 5 divided by 2 is 2, remainder 1, because 5 divided by 2 is 2.5. And now 2, what do we do here? We do 2 divided by 2, and that is remainder nothing, because 2 goes into 2 one time, one whole time. Now we're running out of space here, so I'll just move down a bit. And 1. Now we do 1 divided by 2, which is actually 0.5, so we get the 0 here, and we get the remainder, and the remainder is 1. Now, this is the most significant bit, and up here, this is the least significant bit. And so it means we write down our answer starting from here and going up to here. But let's not do that yet, because we have a second part to do. And this is what makes fractions a little bit more complicated when converting. Next, we have to do 2.50. Now, to convert this, we multiply. So get your calculator out for this one. It's a little bit different. 250 times 2 is 0.5 times 2 is 1. Okay, so we have a 0 here, and so when we multiply, because we're multiplying and not dividing, our most significant bit is actually at the top, and our least significant bit is at the bottom. So we do this. So it's actually 0, 1, not 1, 0. Now, there are other situations when you're doing this where perhaps you're doing a random other number like 644.644. Okay, well, so let's do that for example, because this is an important point I want to illustrate to you. 0.644 times 2 is 1.288. Now we still have a decimal here, and you remember here when we have the decimal and we have a whole number, we keep going. So here we write this number down, we remove it, similar to how we remove the decimal here and keep dividing, we keep multiplying this number. So after that we do 0.288 times 2, which is 0.576. Okay, 0.576, and then we times this by 2, and this is 1.152. So what do? We times 0.152, because remember, we don't times the number, the whole integer number, when we're doing this. So this times 2, and that gives us 304. How long do you do this for? Some numbers can go for so long. Well, the reality is, converting between different number systems is not always precise. So it may be really long before you get the whole decimal point in some situations. A nice clean number like 250 will get you to 1 very quick. But a more complicated decimal, a more complicated fraction might take a really long time, a lot of decimal places, or it may loop. So for example, you may get to a point where you're working this out, and then, you hit 0.644 again. What happens there? Well, what happens there is you divide that, or you multiply that, and it goes back to 268 or 288 again, and then that goes to this, and that goes to this, and it continues, and you get, like blah 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 like this, and you'll get an infinitely looping pattern. It doesn't stop. And that's another thing that is possible to happen. So what do? Well, that will depend on your tutors, of course, but essentially what you do is you determine how much precision you want. And in a computer, you'll have a certain amount of bits that you can use anyway. So you're not going to be able to have a number that's infinitely long. There are different things in computers that can signify if something is repeating. But essentially, if you have to keep going like this, then do as many as you're told to do, or do it till you're satisfied with how precise the decimal point is, because you know that there are things like irrational numbers. There are numbers where the decimal point after, will keep going for ages and ages. So do till you're satisfied. If you're calculating something where you need a certain amount of places, like if you're doing the IEEE format, you will need 23 places. So keep that in mind. What do we do next? Well, it's pretty easy what we do next. We figured out this number, we figured out this number, now we just put them together. Most significant bit here, 1, 0, 1, 0, 0, 1, 1, 0, 0, 1, 0, 1, 1, 0.01. And this is in base 2. So this is the result. Now, don't just take my word for it. If you're doing this, I want you to use some sort of calculator or converter to make sure that this or your number is correct when doing it yourself. Because don't just blindly follow what I'm doing. Choose a number, choose a decimal fraction, and do this all for yourself. So right now, as we speak, I'm actually going to use a converter from decimal to binary. My number is 5323.250, and convert that to binary 10100110001. And yes, my number is correct. So hopefully my logic is correct. I hope this process of converting fractional decimal numbers to binary makes sense to you. In my video where I introduce converting decimal to binary with whole numbers, so not as difficult as this, I go on a little rant towards the end about why this actually makes sense. Why do we get these remainders? And so if you're interested in about that and why these remainders are actually accurate, go and check out that video. But aside from that, thanks so much for watching. Keep enjoying your studies, because this stuff is really interesting once you really dive into it, and I'm sure you'll do well. Thanks for watching.